Welcome back to Stewart Science. Today we're starting a new unit all about energy. Now, simply put, energy is the ability to cause change. And it changes form and it changes items a lot of different times in a lot of different ways. So there's a lot of different vocabulary, a lot of different buckets that energy can kind of be sorted into. Because like I said, it takes many forms. The main unit for energy that we'll use is called joules, Joules, not joules like the crown, joules like the guy, the French guy. And he was a scientist. He did a lot of work with energy, and so we've honored him the same way that the Newton is the unit for force, since Isaac Newton did a lot of work with forces. Joules is the unit for energy. And so there's probably two main types of energy that you are already familiar with: kinetic energy and potential energy. These are just the big buckets. Basically, kinetic energy is energy in motion or in action or some kind of doing something or other. And then potential energy is energy that's stored in one way or in one item or another. Now, the way that energy is usually stored is in positions. So you can store energy by stretching out a rubber band or by bending a spring or by lifting something up. Those are always that energy can be stored. So I actually think a better word for potential energy would be positional energy, because it's all about the position of the object that gives it the energy's storage. Even when you're looking, and we'll talk more about this here in a second, when you're looking at the individual atoms, the way they're arranged, their position relative to each other, that kind of has a big impact on whether the atom will react or not. So we call it chemical energy, and we'll get there. But even chemical energy is still about the position of individual atoms. So the issue thinking about energy is that we have big energy where you have planets in motion, and you have little tiny energy from individual particles vibrating or moving. So energy is on a giant cosmic scale. Astronomical things have energy, and microscopic, eensy-weensy single atoms and molecules also have energy. And so we have to kind of think about the different ways that we can see that energy and how to think about it. So here's a bunch of different kinds of energy. When we've talked about energy in the past, I'm sure we've talked about kinetic energy and potential or positional energy. I'm sure those are words you're familiar with, kinetic and potential. But from now on, I want us to be extra specific, to use better vocabulary when we talk about different kinds of energy. So no longer can you just say kinetic or potential. I want you to be more specific about the kind of kinetic or the kind of potential energy. And these are kind of loosely sorted. There's some overlap in between them, but basically there are a few of these that are in action and there are a few of these that are stored. And so we'll start with the ones that you're familiar with the most. Translational energy is a kind of kinetic energy, so it goes in this category, for objects that are going from point A to point B. They're translating. They're going from one place to another. A car in motion, or you running, or throwing a baseball. Normal, I'd say what you normally think about with kinetic energy is translational kinetic energy. So anything in motion from point A to point B, translational. Now, when you normally think about potential energy, you usually think about things being raised up or lifted off the ground, or an elevator going up, or something like that. That's gravitational potential energy. And so sometimes I'll even call this GPE. So gravitational potential energy is energy that's stored just by lifting an object higher or by being elevated. So if you think upward, that's gravitational, because it's the gravitational force that gives it its energy. Now, another kind of energy that you might not always think about is rotational. So even on that car example, those wheels are spinning. And so it takes energy, or it shows energy, that the object is in motion. Maybe not from point A to point B, but it's spinning around like the Earth is right now. That's a rotational kind of energy. And these two together packaged together when we talk about them together, that's also called mechanical. Mechanical energy is not its own specific type, it's energy from moving. And that moving can be from point A to point B or spinning. So if I throw a fastball or a curveball in baseball, that ball is spinning really fast, which is why it moves the way that it does, and it's going from the pitcher's mound to home plate. So that baseball has both translational and rotational energy, and we call those two, when we package them together, mechanical energy. Now, another way that we could store energy is by stretching out a rubber band, or by pulling a spring, or even like a bow and arrow. If you draw the bow, you have to sort of force to kind of stretch the bow backward. That's elastic energy. If you were ever like me and you're kind of an ornery kid, you would take a rubber band and then some paper and you like shoot people with it. Pulling that rubber band back stores elastic potential energy. So on the potential side so far, we have gravitational, elastic, and like I mentioned, we have another kind here, chemical. That's stored in the individual bonds. And so when you think about things that have chemical energy, one really good example is the food that we eat. If we don't eat food, we don't have energy. Our body doesn't have calories. We can't do things. And so we get tired, we get dizzy, we get a headache. Our body needs nutrients and needs macromolecules, proteins, fats, carbohydrates, so it can break them apart and turn them into the energy that we use. This is kind of a really quick sidebar. One of my favorite characters in all of TV is a guy named Andy Dwyer from Parks and Recreation. He's talking one day, he's kind of like a simple guy, and he goes, "Did you know that the food you eat is energy?" And he like, there's a punching motion. He goes, "That's cheeseburger." And he kicks and he goes, "That's pizza." That's true. What he's doing is true. The food that we eat has chemical energy. Another good example of that would be like dynamite or gasoline or anything that burns also has potential energy, chemical potential energy. And that's why it reacts the way it does. When you see a reaction, that's usually releasing chemical energy from the bonds that are stored in those atoms. Now, another kind of kinetic energy is called thermal. Another good name for thermal energy is heat. Heat is the motion of the individual particles. And so you have those atoms that they are always moving, and the more thermal energy you have, the more they move. And so a solid, they're locked in place, but they're vibrating back and forth. And so when they eventually vibrate fast enough, sometimes they wiggle loose from where they get stuck in that item and they become a liquid or a gas. And so thermal energy is heat. Usually that's kind of like a wasted byproduct of whatever you're doing. Like if your car is running, it's giving off heat. It's not really helpful to your car that it's giving off heat, which is why it has that muffler, that tailpipe that kind of spits it out the back end of your car. So usually thermal energy is not something you want, it's just a byproduct of things that you have. Or your muscles. If you're like working out a lot, you get sweaty because there's friction from your individual muscle fibers moving past each other, and that makes heat. And your body doesn't necessarily want that heat. Sometimes it needs it if you're cold, it's why you shiver. But thermal energy is kind of like it's heat, but usually it's a byproduct of some other thing that's happening. Just a few more here. Radiant energy is another word for light. If like the sun right now, it's giving off both thermal energy and heat. It's giving off radiant energy as light, which is why plants photosynthesize. It's why when you go outside, your skin gets warm. So radiant energy, light is a kind of energy too. Another one that's a kinetic energy is sound. Sound is caused by one air molecule or one molecule, I guess, in any item, bumping into another and passing some of its energy on. And so what actually is happening right now is that you're listening to this through some device that's vibrating the air molecules in the room, which will bump into each other until they get to your eardrum, your tympanic membrane in your ear, which that makes that eardrum wiggle a little bit. And there are little hairs under that eardrum that'll actually pick up those vibrations and tell your brain what it's feeling, and your brain has gotten so good at those little hair feeling vibrations that it can actually put them into the words that I'm saying. You only understand me. I'm wiggling the air in this room, which is wiggling the microphone in my computer, and that microphone is saving those vibrations in sound waves into the hard drive of my computer where I'll post it to YouTube. Then you're going to YouTube and watching it, listening through headphones or through speakers. Both of those things are vibrating the air around them, vibrating the ear. So all of that goes through sound energy twice. Once from my vocal cords to the mic, and then once from the mic to your ears. So sound is a way that energy can be transmitted too. And last but not least, we have mass. Mass is a potential. This is kind of strange to think about, but Einstein's famous equation, E equals mc squared, just means that energy, which is what the E stands for, is equal to mass, m, times the speed of light, c, squared. Now that doesn't change. Speed of light is a number that's stuck in space. But so this basically just means energy can be mass. Wild, right? So in a nuclear bomb, when that nuclear bomb detonates or goes off, the parts that are left after the bomb actually weigh a little bit less. If you could get them all back together into one spot, their mass would actually be less than they were before the bomb went off. Same thing with the sun. The sun's using nuclear fusion right now. It's turning hydrogen molecules into helium molecules, and somehow through this weird equation, those molecules weigh a little bit less after they get fused than they did before. So the sun's actually losing weight over time. Weird, right? But that's what it says. Energy is mass. So those are the different categories of energy and kind of how they're sorted. So from now on, when I ask you, what kind of energy does this have? I want you to be specific using one of these 9 examples. As always, this is Mr. Stewart. Keep learning no matter what.